electrostimulation techniques have been studied. The system can be grouped into low amperage and high amperage systems. Both type of the systems have been used by the processors. High amperage simulators are available for commercial manufacturers. Low amperage systems vary in their conditions and are usually combined with other enhancing procedures. Low amperage systems accelerate rigor mortis development and prevent sarcomere shortening in the breast fillets after deboning. While the high amperage system also induce the additional effect of myofibrillar damage to further improve the tenderness. Main stages in the poultry refrigeration. There are three main stages: chilling, freezing and cooling. Firstly, we will discuss the primary chilling stage. The chilling is required to prevent the growth of most foodborne pathogens and delay the growth of spoilage organisms. Overall, the choice of chilling system is based on a combination of economic, hygienic and legislative factors and the market demand. Air and immersion and spray systems are the three most common methods of chilling used for breast carcass. The term spray covers a number of different options and is sometimes referred as evaporative air chilling. It is thought that only one true spray chilling system rely on a large quantities of refrigerated water, about 12 liters per bird, sprayed continuously on the carcass. Spray chilling installations use very large volume of refrigerated water produced microbiologically. Results can be compared with those obtained in well-operated controlled immersion chilling systems. Spray chilling systems rely on intermittent sprays, for example, at 5 and 15 minutes after the start of the air chilling on 4 or 5 occasions during the whole chilling process. The principle of the process is to increase the rate of evaporative heat losses by replacing the water lost during the overall weight loss. Poultry carcasses were placed in a vacuum chamber and then cooling rate produced were similar to those achieved in the immersion systems. Water immersion chilling systems were initially operated to maximize the weight gains, where carcass is immersed in water at a temperature of about 12 degrees centigrade, where they absorb between 12 to 15% of their weight. They were then transferred to water at 1 plus minus 2 degrees centigrade to complete the chilling process. The countercurrent immersion chilling systems are used with a maximum water inlet temperature of about 4 degrees centigrade. Dwelling time and degree of water agitation are controlled to limit the water absorption by the carcass. The chilling rate in an immersion system are usually far faster than those achieved in the air. With the spray chilling procedure time in between air and immersion methods. Plate contact cooling was found to be no faster than slow moving air at 0 degrees centigrade. Cooling times from about 40 to 10 degrees centigrade in the plate system was approximately 5 hours for 2.5 to 3.5 kgs of unevaporated carcasses. Chilling rate in immersion systems are a function of the cooling medium used, its temperature, the size of the carcass being chilled, whether it is wrapped or unwrapped. Typical immersion in slush ice is far more effective than water immersion at the same temperature. Unwrapped carcasses cooled far faster than those that were wrapped. The effect of wrapping being a doubling in the cooling time in some cases. Next stage is freezing. Poultry meat for further processing is usually frozen in the form of carcass or bone-in or bone-out portions in the carton weighing up to 25 kg. Most bulk meat, consumer portions and other poultry products are frozen in air blast freezers. Some small individual items such as chicken burgers may have been frozen in cryogenic tunnels. And a small amount of offals mechanically recovered meat and other meat is frozen in plate freezers. It is not unusual for poultry meat to be frozen twice before it reaches the consumer. During the industrial processing, frozen raw material is often thawed and tempered before being turned into pies, convenience meal, burgers, and etc., or consumer portions such as breast fillets. These consumer-sized portions are often refrozen before storage, distribution, and sales. Air freezing of poultry carcass showed that different freezing conditions could result in freezing times from less than 5 to over 35 hours. Different freezing rate result in substantial differences in the ice crystal structure of the muscle tissue. Immersion freezing is far faster than can be achieved in air freezing system. In blast freezing of chicken carcass, both air temperature and air velocity have substantial effect on the freezing time. Secondary cooling stage. The poultry carcass must be chilled immediately after dressing. It is critical that the average temperature of the carcass is reduced below 4 degrees centigrade and preferably to a temperature approaching 0 degrees centigrade during the primary processing. Any subsequent handling process such as cutting, mixing and tumbling will add heat to the meat and increase its temperature. A secondary cooling operation is therefore required with all raw poultry products to reduce their temperature to approaching 0 degrees centigrade and maintaining their storage life. Rapid cooling is also required after cooking of the poultry to prevent growth of any surviving microbes. There is a little published data on the cooling of cooked whole carcass or poultry portions. Cooling from 85 degrees centigrade to 10 degrees centigrade took almost 9 hours. Usually take about 9 hours in the air where temperature is maintained at 0 degrees centigrade at a velocity of 1.2 meters per second, almost 7 hours in ice water and 36 minutes in vacuum cooler. Although the vacuum cooler is substantially faster, weight losses approach up to 8%, almost 4 times greater than that in air. In cured meat, cooked and cooked poultry products, 70% chicken. Population of Clostridium perfringens remain relatively unchanged during chilling from 54.4 degrees centigrade to 7.2 degrees centigrade and decline slightly during refrigeration storage under vacuum at 4.4 degrees centigrade. That's all for this lecture. Thank you so much. We will discuss some other poultry preservation techniques in our next lecture.